All right, guys, so today we are going to start with arithmetic sequences. We are starting our next unit, Unit 3. We're going to talk about arithmetic sequences. Here's a vocab word for us. A sequence is a list of numbers that are in a specific order. So notice it goes 1, 3, 4, 7, 10, 16. All of these individual numbers are considered terms. So another definition would be the word term, but we already know this. Arithmetic sequences. So sequences are arithmetic if the differences between consecutive terms are the same. So when I look here, how do I get from 4 to 9? We plus 5. And what about from 9 to 14? Plus 5, plus 5, plus 5. So I know this is an arithmetic sequence because it has a common difference. The sequence has a common difference. Just like it says here. We want to look for common differences between terms. So when I look at this first example, I see we go from 2 to 4, which is plus 2. And then we go from 4 to 8, which is plus 4. And then we go from 8 to 16, which is plus 8. Those are not the same numbers. That's why it is not an arithmetic sequence. We look at the second example. This one is minus 3 from 48 to 45. And then again, minus 3. So yes, because D, our difference, is minus or negative 3. So now let's look at a few examples. Is this an arithmetic sequence? And if so, what is the common difference? Well, I see here from 35 to 32, I do minus 3. And I do minus 3 again. And minus 3 a third time. So yes, it is, and our difference is minus 3. Negative 3 to negative 20, that's going to be minus 20. From 23 to 43 is again going to be minus 20. And 43 to 63 is also minus 20. So this is also a sequence where D equals minus or negative 20 this time. And we quickly see that this one is also, this one's minus 30. So yes, D equals negative 30. Over here, this is also one because it goes by minus 10. So yes, D is negative 10. Over here from 7 to 9, we go with minus 2. 9 to 11 is minus 2. And 11 to 13 is minus 2. What about this last one? This is plus 5 every time. So they're all arithmetic sequences. These two formulas are extremely important, so we need to make sure that we write them down in our notes. Recursive and explicit. Recursive we use if we know the first term. Or if we're looking for the next term, I'm sorry. Am I lying to you? No, it's if we know the first term. And explicit means we do not know term one. Did I do that backwards? I did. I wrote that a little wrong. So let's change these. Recursive would be finding the next term. So we need next term. Explicit would be need any term. And this is the big difference is needing the next versus any. So down here, we know A of n stands for whatever term I want. A1 is the first term. N is the number of term. And D is our common difference, which we already know how to find. So let's go ahead and start using the formula. Now we are looking for 34. I don't know, or they gave us an equation, so all I need to do is say that 34 equals n, because it's the number of term we're trying to find. It's the 34th term that we want. So for this, I can just take n and substitute in 34. A sub 34 equals negative 11 plus 7 times 34. Seven times 34 gives me 238 minus 11 gives us 227. So let's try on the next one. Again, they already gave us the equation, so we don't need to worry about that. And we are saying that n equals 39 because it's right there. We're looking for the 39th term. So A of 39 equals 65 minus 100 times 39. 100 times 39 and 65 minus 3900 gives us negative 3835. What I want you to do is go ahead and do 9 and 10 for me. I'm going to skip them. You can check with me in class to see if you got the answers right. These next problems want us to create the sequence and find the first 5 terms. And we are supposed to give an explicit formula. So let's double check and make sure we remember explicit. So explicit is AN or A1, where's my little A1 plus N. I'm going to put D out front, the N minus 1. Correct? I like to have the D in the front, not in the back. So that's why I personally moved it, but it doesn't matter either way. So now we can remember what our explicit formula is. That equals AN. I know my A1 and I know my D. So we can go ahead and create our formula. So A sub N equals, and we're just going to substitute A1, so 28, plus 10 times n minus 1. And there's our explicit formula. Now we need to give the next 5 terms. So A1, A2. Now what I'm saying is n equals 1, so anywhere I see an n, I'm going to put a 1. So A sub 1 is 28 plus 10 times 1 minus 1. Oh, we already know the first term. I don't know why I'm trying to find it. Just go with 2 and 3. Plus 2 minus 1. 2 minus 1 gives me 1. So I'm going to end up with 28 plus 10, which gives me 38 for that term. And the second term, I could also say, well, I know every time it's going to grow, it's going to get larger by 10. So I could also, for this one, just say 38 plus 10 equals 40. So we need to go ahead and solve. We'll do 12 as well. So I'll do 12. I did not do 4 and 5, but I assume you can probably plus 10 to get your answer. So we have our equation. So we're saying a sub n equals, instead of a1, we're writing negative 38 plus negative 100 n minus 1. And again, I already know first term is negative 38. And now I can also say, just subtract 100 every time. But we'll do it the way that we should first. So a sub 2 is going to be negative 38 plus negative 100 times 2 minus 1, which gives me negative 38 minus 100, which is negative 138, which means a sub 3 would be negative 138 minus 100. So we'll get negative 238. We can keep going with that process. I want to do a few word problems with you as well. Jerry deposited $20,000 in an investment, and he gets back $1,750 for every year that money stays in his account. How much will he have at the end of year 8? Every year. So we know a sub 1. Actually, well, we'll call this a sub 0 because this is before year 1. A sub 0 gives me 20,000. My difference is going to be 1,750. And we need to figure out year 8. How much am I going to have at year 1? Year 1, I'm just going to go 1,750 and add it. So this is how much I have for year 1. And we want year 8. We could use the recursive formula or the explicit. We could just sit there and add that number every time, but using our explicit formula makes it a lot easier because I have a sub 8. Actually, we'll do a sub n right now. It's going to give me my first year times our difference, n minus 1. And remember, that's at the end of year 1. We're talking about the end. So at the end of year 0, all we have is the original amount of money. So if we want to find year 8, we just plug in 8, 21, 750 plus 1750 times 8 minus 1, 21, 750 plus 1750 times 7. What is 1750 times 7? And then we add those two numbers together. And we get 34,000.